Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT ONE, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Saar Yoskovitz, CEO of Augury. Augury eliminates downtime and improves productivity with world-leading machine health diagnostics. In this talk, we discussed how manufacturers can save millions in CapEx and excess inventory by unlocking the shadow factory hidden in their operational inefficiencies. We also explored the value and complexity that comes with providing a full stack solution that integrates hardware, software, and services. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you'd like to discuss, you can email me directly at erik.walza@iotone.com. Thank you. Saar, thank you so much for taking time to join us on the podcast today.
Thanks for having me.
So I always love to speak with founders and CEOs because there's always some interesting backstory, right? So it's not an easy thing to do to quit a well-paying job and dump a lot of time and often at least lost income, if not personal savings into a new company. Maybe this is a good place to start. Can you just walk us through the path that took you to set up Augury? I think about 10 or 11 years ago.
Sure. Yeah. So we have two co-founders at Augury, myself and my partner, and we actually met during university. So both of us are from Israel. We studied. We have an engineering background. We studied in the Technion, which is similar to MIT. It's a tech-focused university. We became very good friends really quickly, and we spent 5 years just talking about different ideas and businesses and opportunities. And it was clear to us that someday we'll start our own business, right? We'll kind of partner up and create something that provides impact to the world. Specifically, at the time, I was studying speech recognition using machine learning and AI techniques. And, we'll talk about what we do, but what we do today is very similar to speech recognition, right? We listen to machines, and based on the noise or the sound, we can tell you what's wrong with them. So instead of searching, we take an audio wave, and instead of searching for words, we search for patterns that indicate different malfunctions. So the core of the technology kind of came from there, and both of us had background in our military service in Israel. We had background working with large machinery. Gal, my co-founder, was in the Navy. I was in the artillery force. When your life depends on a big machine, you become very intimate with it. So you learn how to recognize every squeak and every sound that it makes. And it was pretty natural for us to kind of take this into the understanding that we can diagnose machines based on the sound and the noise that they make. And then we asked ourselves, okay, what type of machines do we want to diagnose? So we started kind of talking to different markets. We talked to commercial buildings, we talked to factories, we talked to automotive car fleets, we talked to overseas shipping, until we kind of found out this whole world of predictive maintenance that is already, has been in existence for 20 years back then. And we found a huge gap, right? So the same techniques and methods they were using in predictive maintenance haven't changed since the 90s. And we felt, at the time, it was 2011, we already had the iPhone, we started to have, I think, Alexa emerge or Google Home. We started to see kind of the insurgence of AI for speech recognition. And we said, maybe we can marry the world of internet age technologies and with the industrial market and really kind of revolutionize or democratize predictive maintenance. So that's how we kicked off.
Yeah. It's an interesting point. And I hadn't planned to start here, but maybe we can dive into this a little bit more. So maybe probably the top 5 use cases, let's say, for IoT are going to be machine vision, predictive maintenance, and speech recognition. How do those differ in terms of the algorithms or the way you might approach them as a solution developer?
The chicken and egg problem of any AI company is that without data, you cannot develop algorithms. Without algorithms, you don't have any value to provide to customers. And without customers, you don't have data. Right? So it's like this vicious cycle. And you need to break free of it. Now, when you look at speech recognition, you can go online, you can scrape the internet, you can look at movies, and there are different sources of data that you can create. When you go into our market, this data set never existed. So yes, predictive maintenance has been around for 20 years, but it was siloed on desktop computers. No one really aggregated all this data, so we had to create our own data set. Fast forward to today, we have over 150 million hours of machines that we've monitored, over 90,000 machines we've diagnosed, and all this data sits in our cloud, right, in our servers, which enables us to continuously refine the algorithms and improve the accuracy or create new types of insights on it. So the first challenge when we started was actually, how do we get all this data? So that's one big difference between image-based, where you have tons of data sets for image recognition and maybe speech recognition, when you have huge data sets, versus when you get to the more kind of, I would say, niche problems that you're trying to solve, it's just very hard to get the data to begin with.
That's a great point. So this is very protective. I mean, even if you have this in the cloud, I think it can still be challenging, right? Because customers, I don't know, do they try to silo their data? Do they allow you to kind of cross-analyze data sets? And I mean, obviously, there's a big value proposition. It's kind of everybody wins by contributing some fraction of insight to this algorithm. But nonetheless, people are still quite sensitive about their machine data.
We were very adamant from the beginning, right, that the customer owns all the data. It's their data, but we get a irrevocable license to use the raw anonymized data, right, for our own kind of research purposes. And in the beginning, it wasn't that clear for people why they should do it. But I think over time, they started kind of seeing the benefits emerge. We had a conversation with the chief supply chain officer of Colgate sometime last year, and he told us, I don't want to win over my competitors because I'm better at detecting bearing wear. I want to win because I have a better product, I understand my customers, I'm better at marketing maybe. But if there is an opportunity to have societal impact, right, reduce energy consumption, reduce water consumption, and by doing so, I kind of, rising tide lifts all boats, then the industry should come together. The industry should pull in all the data in order to provide that massive gains on environmental and sustainability. So that's his view, and I really appreciate it. And we're seeing more and more companies share it.
That's great. No, I remember, this was also about 10, maybe 12 years ago when I was doing my MBA. And there was a case study, which was actually Pepsi and Coca-Cola. And I think it was exactly around, I don't know if it was predictive maintenance, but it was some type of algorithm deployed on production equipment to improve efficiency, and that they would not agree to this. And so the case study was basically like game theory problem, right? There's a win-win, but both companies prefer the suboptimal solution because they have some concerns around this. And I think later we're going to discuss a case on Pepsi. So it's great to see that there's been somewhat of a mindset shift in the decade since.
There has, and also we work with vibration data, magnetic data, temperatures, kind of the more mechanical data set. Today, we don't rely on the operational data set, or so the recipes, and that's typically where companies will consider their secret sauce. So to begin with, the data we work on is less confidential, and they're easier to share.
I want to get into the evolution of the technology later on, but let's start with the value proposition. And maybe we can begin with a concept called the shadow factory, which we were discussing by email. So just outline this for us and explain why this is something that manufacturers should care about.
I mentioned we started 10 years ago as a predictive maintenance company. And over time, as we had more of these conversations with everyone from the plant level to the corporate kind of executives, over time we figured out that predictive maintenance or machine health rather is not a maintenance problem. It's a supply chain risk management problem. So it goes way beyond just maintenance. That's why we also started using the moniker machine health and kind of are moving away from just maintenance. And today, companies operate under an assumption that machines just fail surprisingly, randomly. Once you ask them, hey, what would you do differently if machines won't fail, stopped failing, right? How would you change your operations? You see these ripple effects. One of them is what we call shadow factories. So the largest cement manufacturer in North America expects that we will help them increase capacity that is equivalent to 2 full factories. So you could imagine the CapEx investment that is needed to build 2 cement plants, right? It's roughly $1 billion. But more importantly, I would argue you can look at the environmental impact of building 2 cement factories and the challenge of hiring hundreds of people. Talent is a huge problem these days in the manufacturing industry. So hiring the talent and the CapEx and the environmental targets that they have, we're not talking about, hey, I helped you detect bearing wear or I helped you detect cracked rotor bars in the motor. You're talking about how can I help you reduce CapEx by $1 billion. So that's the notion of kind of shadow factories. Full factories are just hidden inside inefficiencies today. And if you could just work smarter and apply different technologies and digital tools to help you be more productive, you can basically increase capacity. And we've seen this over and over with I would say most, if not all, of our customers.
Yeah. Okay. This is a great point. How do you do that? Because I think a lot of companies do focus on a lot of technology companies do focus on the KPI and say we help you improve some metric for this piece of equipment. And like you said, it's probably not a very smart way to sell, because then you are building a business case around maintenance budgets. But to move beyond that, you have to understand how improving performance in specific aspects of a factory can help unlock additional production capacity, which means also impacting forecasting, and the group of stakeholders that are somehow involved in making decisions around this becomes much broader, because you're dealing with management level decisions around how much we produce at this factory, as opposed to dealing with a production unit that's responsible for maintaining some pieces of equipment. So how do you approach this then as a business? Who are you engaging with, and how do you broaden your perspective beyond the equipment that you're touching with your algorithms to the operation of the factory as a whole?
We really believe that we're not here to sell a technology. We're not a sensor company. We're not an AI company. We're a machine health company, right? So we come in to solve a very specific use case that I would argue all of manufacturers, everyone who owns a factory today is struggling with. And that is, again, the fact that machines just fail unexpectedly. And we always search for that. We go in with that use case, right, to begin with. And then we start with a very basic foundational level of let's make sure all your machines work, right? Let's put this on all your factories, on all your critical machinery, and let's make sure that they just stop kind of bleeding with unexpected or unplanned downtime. And after that happens, now we can go into that kind of second order and say, hey, if machines stopped failing, why do you have $50 million worth of captured spare part inventory sitting around collecting dust, right? Just waiting for something to fail. Maybe if we can commit to giving you a 2-week lead time on any malfunction, maybe you can just have a regional warehouse where you can ship it overnight, right? Ship the spare parts overnight, right? So that's one kind of second order impact. If you can, why do you keep so much product inventory? Because machines tend to fail. I need to be ready, in the case of supply chain disruptions or whatnot. So, well, if we can help decrease the risk of machine failure by 80%, maybe you don't need as much inventory. Maybe you can become leaner. Maybe we can enable this just-in-time kind of philosophy that you're shooting for. So we start with kind of the very basic level. Let's prove our worth. Let's get very quick time to value. And today, within a month, all of our customers get full payback of the whole annual program. And then we build from there.
Okay. Interesting. And the type of machine, are you building this kind of one category of equipment? Like, say we start with CNC machines, and then we move, we add categories kind of organically based on customer demand? Or is the algorithm flexible enough that you could deploy it on an entirely new type of machine that you haven't worked with previously, and it would learn how to function within a relatively short period of time?
Great question. So today we're focused on the process manufacturing industry. You mentioned CNCs as an example, is on the discrete side where we don't support or we're not active today. But on process manufacturing lines, we cover 80+% of the most critical machines, regardless of the industry, right? So we have CPG and food and beverage and pharmaceuticals on one hand. We have cement manufacturers and building materials and metal and plastic manufacturers. So we're very wide in our ability to cover, and we only have one type of sensor, right? Or one type of hardware that includes vibration, temperature, and magnetic data. That enables us to provide a holistic view of an electromechanical system. Now, the algorithms may change a little bit depending on the type of machine. If you're looking at a pump, you're looking at, you're solving for very specific malfunctions that happen on a pump versus a compressor versus a larger, servo motor driven machine. So the algorithms may change, but the hardware, the basic sensing elements are similar. Out of the box, we cover 80% of the critical machines, and then that other 20% we can build over time.
Yeah. Okay. Got it. Makes sense. And I think this focus on process manufacturing makes a lot of sense here, obviously, because they have a huge CapEx investments, but also just focusing on a set of customers that have a similar set of problems. It's always a good decision. And, I do a lot of interviews, and I hear a lot of companies that are probably covering 2 or 3 times more industries than they should. You're working with process manufacturers. What about the equipment OEMs themselves? Do you have direct business relationships with them? Is it more of a partnership? Are they customers? How do you engage with those companies?
That's a great question. So the answer is yes. We work both with the end user, let's call them Colgate and Pepsi that you've mentioned. And then we also work with manufacturers of the machines that go on the production lines or in facilities in general. So today we're partnered with Grundfos, which is the largest pump manufacturer in the world, as an example, and Carrier, the largest chiller cooling company in the world as well. And we have others that I can't share. And their goals differ. I would say there's a larger trend in the industry of getting to outcome-based services, or water as a service as an example, or cooling as a service, or whatnot. We're kind of helping usher that change. What you find out is if the OEM starts charging per gallon of water instead of selling a pump, and the pump doesn't work, then they're not getting paid. So the risk of downtime just shifted from the end customer to the OEM. And obviously, as I mentioned, our system helps reduce that risk by 80%. So we're helping them build kind of the backbone of technology. How do you connect and monitor every machine? And our vision eventually is, we'll have embedded machine health in every machine that goes off their production line. Okay,
interesting. Yeah, I want to dive into the business model because I think there's a lot of room for innovation there. But before we jump into that, just to understand a bit more of the solution and the technology, you've already given us a bit of a overview, but can you just paint us a quick picture of where you're coming from, where you are today, and where you would like to be in maybe 3 to 5 years? Because I think it's always interesting to understand how technologies that have tech stacks that have some aspects which are kind of exponential growth in terms of maybe the volume of data you have or processing capability, and then other maybe aspects of the tech stack that are improving at some single or double digit percentage per year in terms of effectiveness. How does that change look like? So it sounds to me like you've had a fairly similar tech kind of solution for about 10 years now, but I imagine the efficacy has kind of evolved significantly. So can you just quickly, what was version 1 look like? Where are you today? And then if you fast forward maybe 3 years or 5 years in the future, where do you expect to be?
So when we started Augury, we intentionally made the decision that we want to be a full stack solution, from hardware all the way to AI and now also professional services as needed. And today, 10 years later, we are still on that track. And being a full stack company has a number of benefits. First of all, it's very hard. So let's not put that aside for a second. Building a company that does both hardware and software is kind of two clashing DNAs and cultures. And making them work and mesh is really hard, and we built it from the ground up, so we became pretty good at it. There is a flywheel of innovation that happens when you're a full stack company. You can look at other markets as an example, Apple, iPhone versus Android. And I'm an Android guy myself, so it hurts me to say this, but the reason that the iPhone scrolls so much better is because they control everything from the CPU, where they create specific modules that enables their software developers to create specific functions that leverage this hardware. Whereas if you need to build a general purpose solution that works with all these different SKUs and systems, it's much harder to get that level of fine tuning. And in our case, our first product was a handheld device that connected a portable diagnostic tool that connected to an iPhone or an Android, a smartphone. And then a technician would go to a machine, attach the sensor with a magnet, collect the data. The data was sent to our cloud. We diagnosed it and returned the results to the smartphone. That was our first solution. After we got to 50, 60,000 recordings and our algorithms, as I mentioned, our biggest challenge in the beginning was getting data, creating that data set, right? So that's how we built the data set. After we had the 50, 60,000 kind of machines that we've recorded and diagnosed, we compiled all of that knowledge into our second generation of hardware, which is a continuous diagnostic solution, right? The sensors, what we call Halo today, where you physically attach the sensors to the machine, connect them to the cloud, and they send data continuously, and we diagnose it. Now we have 150 million hours of data, of machine data, and we're compiling all of this into our second generation or third generation of hardware, right? So there is this, having our algo developers and our hardware developers sit in the same room is really powerful. It enables us to continuously bring innovations to the market that provides this kind of 2 to 3 year lead versus other sensor manufacturers or AI companies that don't have hardware.
Yeah, it does make sense. And if you look forward into the future, any significant changes that you anticipate, or is this more of a continuous improvement process?
On the kind of machine health side, we're continuously working to provide more coverage, right? So more coverage means today we're on the critical machines. How do we go to smaller, less critical machines? And last year we launched kind of Halo for supporting equipment that enables us to go to smaller machines that are maybe less critical, more redundant, and whatnot. Increasing coverage also means let's go to machines maybe that are not rotating at all, right? So there are other types of systems in a factory or in the industry at large that are non-rotating equipment. And today we can maybe tweak the hardware a little bit, tweak the algorithms, and create a full stack solution for other types of systems within a factory. So that's kind of on the machine health side. And Moore's law continues to march on in our domain, and cost of sensing goes down by 90% every couple of years. So we expect the next generation of sensors to be smaller and cheaper and better power consumption. And eventually you get to a sticker that you put on the machine, right? We're not that far away from it, maybe 5 years. Now, another thing we're looking at is how do we marry the machine's health and behavior to the quality of the product that the machine is manufacturing, to the throughput, to the yield, to the sustainability and energy consumption, right? So connecting between machine health and what we call process health is very powerful. And today we're already seeing the lines blur a little bit between these two worlds. And to me, that's the exciting part.
Yeah, absolutely. No, it's funny. I just probably a month ago, I was interviewing a company called Wiliot, which does exactly this, basically sensors on a sticker using Bluetooth. They're using them for supply chain right now because they can basically track location and temperature, and you can start to add a few more sensor parameters. But I would say they're certainly not going to be robust enough to collect the data you need. But you can see that, yeah, if you fast forward 5 years into the future, the technology will get there. So you just have to keep building on top of also other people's innovations here. On the business model side, also there's been a lot of progress here. So you were already starting to discuss the topic of kind of shifting from I sell you a pump to I sell you the ability to pump a gallon of water per second or whatever that might be. And if you're in the position of being able to tell a manufacturer, we can save you $1 billion of CapEx investment, I mean, that at least has the potential to be a much more attractive business model than we want to sell you, $10,000 per production line, per year or something, like kind of a SaaS solution. How does that look today? Because I think this is still a very new concept that a lot of both tech companies and manufacturers are trying to wrap their minds around. Are you already having kind of uptake in this business model, or where are you today here?
Yeah, so the notion of performance-based models or business models, is definitely there, and it does make sense. I don't think the market is mature enough yet for it, and maybe we as a company are not, as an organization, are not there yet as well. But that is definitely where the market is going, right? So, we decided to begin as a pure SaaS model. So we are purely OpEx. We do have hardware, but we just give it away for free and charge on a recurring basis per machine per year. So that's where we started, which was already very forward thinking. If you can imagine, 5 years ago, 6 years ago in the industrial market, there was a lot of pushback for this model. Even today, some companies would prefer, a $3 million CapEx in a one-time fee versus an ongoing SaaS-based recurring model. But a couple of years ago, we launched what we call guaranteed diagnostics, where we partnered with Munich Re, which is the largest reinsurance company in the world. And it took us 5 years of working together to get the confidence of their underwriting team in the accuracy of our system, right? In order for them to back our diagnostics with their own financial products. So today, if Augury says a machine is working well and for whatever reason it fails, we will cover the replacement cost of the machine, both the parts and the labor, right? So this is the first time we're seeing insurance-backed AI diagnostic solutions in the world, not just in the industrial market. So if you look at the healthcare, we're seeing more AI diagnostic solutions, and they're not insurance-backed yet. So this it was really groundbreaking a year and a half ago when we launched it. And we're continuously working on how do we refine it, right? How do we get to the holy grail of manufacturing, which is uptime assurance? Right? Not only do I cover the cost of replacing the pump, I also cover the production losses due to a downtime event. And when we get to uptime assurance, then it starts looking like a performance-based model, right? But it's still driven through a very specific use case and very specific calculation of value.
Yeah, interesting. Yeah, because then you have kind of 10x the risk for right? So that's a lot of liability to cover. But if you have sufficient accuracy in the algorithm and you're spread across a large enough set of customers, then you could diffuse the risk, and it starts to act like you insure airplanes and you insure other things that could be $100 million hit. But as long as you're covering enough assets that are diversified, then you can build a model there. How does this work with Munich Re? So they basically kind of integrate a service fee for this insurance product into your fee that you're charging to customers, or what does that look like?
Yeah, so for the customer, it's streamlined, right? They only interface with Augury, and we on the back end of things kind of have our own agreement with Munich Re that kind of covers the risk there. So not to get too deep into insurance mechanics, it's supposed to be as simple as possible for the customer.
So very interested, first of all. I mean, I've heard of a couple other cases of people exploring this, but I think you guys are sitting at the front of the market here. If we can return, let's see, for a moment to the simpler question of why somebody might prefer a CapEx over SaaS. Why do you think this is? Because if you look at a B2C market, I guess there are a lot of areas where we do also prefer CapEx to SaaS. But when we start talking about, in terms of hardware, at least, we prefer CapEx to leasing, right? But when you talk about software, the market's pretty much gone to SaaS, right? Nobody's going to pay Spotify 5 years or 10 years or kind of a fee to own it permanently. So the value proposition is very clearly superior. And it feels like in B2B, it's also in most cases clearly superior. Do you think it's more kind of just the production processes, the accounting processes, and maybe tax credits? Is that kind of what is preventing companies from adopting this model?
To generalize, I would say that if you look at broad enterprise B2B, the SaaS markets have year over year continues to grow exponentially. So there's definitely openness to, and maybe companies prefer purchasing in SaaS. On the IT side, the OT, operational technology, are not as used to it, right? So and that's how their budgets are structured and how their ERP system is structured, and they allocate different. But if you look at the maintenance budget of a manufacturing company, they have a CapEx bucket and they have an OpEx bucket. And the CapEx is larger than the OpEx because that's how they're used to working. I need to purchase a new machine at $1 million versus get a service that is ongoing. So this is historical, and I expect it to change over time because the benefits. I'll tell you what I tell all of our partners and customers. Right, we chose to be a SaaS company for a host of different reasons, but the biggest one is that it aligns our success, Augury's success, with a customer success. Because if I sell you $2 million worth of sensors and then I just disappear and you fail, then I'm happy. I did my job, right? I got my quota. But if you're a SaaS, if we have a SaaS model, every year, right, you need to reselect us as your vendor. And if we're not doing a good job, you can just fire us then and there. So we're very much aligned that we need to continuously do a good job in order to make you successful and win the business every year. And in order to do that, we continue to provide services. We continue to build our product, right? So if you look at our platform today versus where it was a year ago, we have hundreds of engineers working day in, day out on adding new features without increasing the price, right? Continuously adding more and more value to the platform. And this is why having a SaaS model really aligns to both the long-term strategy of our customers as well as the ongoing day-to-day service and both the product technology side as well as the people customer success side.
Yeah, no, very well said. So yeah, you're right, though. The market is moving in that direction. It's just there's obviously some institutional challenges in changing for large organizations. Let's do a case study. I think the Pepsi one would be great if you can walk us through that, because it's, I think, now going to be interesting to look at what the journey looks like from identification of a problem to kind of scoping out the solution, deploying it. And if you can start with who are the stakeholders here, right? So who are the buyers, who are the influencers, and who are the users of the system, and then just walk us through that process.
That's a very good distinction between kind of the buyers and the users, right? So we are proud of our ability to work both on the plant level, the maintenance technician level, all the way up to the chief supply chain officer, because you need both in order to be successful. Corporate team can make a decision, spend a ton of money, but if there's not the proper habit forming on the production line and acceptance of technology on the production line, then they're going to fail, right? So we go kind of bottom up and top down at the same time. We find the main decision maker to be the VP of manufacturing or VP of engineering solutions, depending on the company. And increasingly, we're also seeing the IT department play a bigger role. So we had a couple of global rollouts that have been funded through the CIO's budget. And there's this, I would say, battle, but hopefully it's more of a partnership between IT and OT, where traditionally, who's going to set the vision for digital manufacturing or Industry 4.0 or whatever you want to call it? Is it the practitioners that understand the challenges of operations and maintenance, or is it the IT people that understand the challenges of security and data lakes? Who's going to set the vision of what this may look like? And increasingly, we're seeing more and more the IT team getting involved, which I believe is a great thing, because they know how to build scalable programs and scale really globally, whereas the OT historically haven't had this footprint. So these are kind of the main personas we work with today.
Okay, great. And then if we look at this, maybe just this case in particular, and you don't have to talk about specific individuals, but can you walk us through the selection process for Augury and then through deployment and what the outcome looked like?
Yeah, so we're seeing in the last, I would say 3 years, right? A year before COVID hit, we started seeing a a change in the market, and COVID just accelerated tremendously, where companies already have a strategy, right? They worked on their Industry 4.0 strategy, on the digitization strategy, and they come a bit more well-baked to the conversation. We obviously help them providing our view and what we're seeing working with other companies like them to help build it together and help them shift kind of their vision and strategy. But they're a bit more better baked now than they were 3 years ago even, right? So they already know. We're seeing more RFPs as an example, requests for proposals. So we're seeing more of that, which is an indicator of market maturity or industry maturity. We typically come in, work with, again, the corporate executives, VP manufacturing and reliability under him or her, in order to identify the right test facilities. We initially start with 2 or 3 factories as a proof of value. As I mentioned earlier, in under a month, they get full payback of the annual program. And we start expanding, right? Going from those 2 or 3 facilities to 20 or 30 factories, depending on the company, and is it regional or global?
Got you. Okay. Okay, great. Would it make sense to dive into a particular case like this PepsiCo Labs and the Frito-Lay case, or is each case sufficiently similar that there's not too much to digest in terms of the...
Yeah, we can definitely do that. So we have a number of examples that are kind of publicly shared. Frito-Lay, there is a video you can maybe share in the notes of the podcast where they kind of share our journey going from a 4-factory rollout to 30-some factories. And the trigger point for them is that within the first 3 or 4 months, we were able to help them manufacture 1 million pounds of Cheetos and Doritos. And they expect, as we rolled out across all of their factories now, that we increase capacity by 4 months, right? Going back to the notion of shadow factories, right? When they get to 12 months of increased capacity, that's a full plant that they don't need to build. So that's kind of PepsiCo, and we've been working with PepsiCo Labs, which is their innovation team that are just tremendously impactful, and they have a really good setup there. Another example is Colgate. Colgate, within the first 4 months, we helped them manufacture or avoid a failure that would have cost them 2.8 million tubes of toothpaste. Now, obviously, they know how to turn the number of tubes into dollar signs, and they had very, very fast ROI. And they claimed that within 3 months in 1 factory, we paid back a full year in 6 factories, right? So that made the decision very easy for them to roll out across their full global portfolio of both Colgate and Pet Hills, which is an organic pet food company. So we have multiple examples like this where we saved millions of dollars in that first engagement. And what's very important as we go into these conversations, even before we actually sign any agreement, is to make sure that they understand what they're trying to solve for. What are the KPIs that they're looking to prove? Because if you don't know what you're looking for, the experiment is going to fail, right, by definition. So we make sure that they have set KPIs, and also they are set up to quantify the value, right? Because the worst thing we can do is, 6 months go by and we help them avoid 10, 20 machine malfunctions, but they don't really know what it means. Is this machine critical? How many hours of downtime did we help you save? What is how many dollars per hour do you manufacture? Is it $10,000? Is it $100? Are you looking to focus less on capacity, but more on reducing maintenance and repair costs? Okay, so what is the baseline we're measuring against? What was your kind of M&R spend in the last year? So really we want to make sure that we have all of that set up kind of before we even engage in the proof of value. And that really helps everyone make a faster decision.
So you mentioned that you're kind of full stack and that you also provide services. Is that one of the services that you provide? So if somebody doesn't have that data available, would you kind of go through a 6-month process of helping them to acquire some historical data here? Or do you just maybe advise them through this, but this is an activity that they would do themselves or with a system integrator?
Yeah, so typically we work with more mature companies. Fortune 500s and or Global 1000s, and they already have a CMMS platform that has been rolled out, or they're rolling it out now as we speak. They have some of the data available. We do provide, the what we call the foundational work of reliability, right? So doing the asset criticality, making sure we have the ROI kind of calculator. So if something does happen, we know how to quickly quantify it. So yes, we have a very kind of consultative approach in our sales, and the goal again is to make the customer successful, because if they're not successful, we're not successful. So how do we have a better setup going into these proof of values?
There was a point that you mentioned that you were working with PepsiCo Labs, which is an innovation kind of driver at PepsiCo. Is this typical? Because so I'm sitting here in Shanghai, and we work a lot with innovation centers. A lot of companies are trying to basically figure out how to localize their technology, often on the product side, but also on operations in China to some extent. And so they're setting up these labs. But I would say typically the ones that I see are more focused on the revenue side of the business as opposed to operations. But are you seeing a trend here where these labs are also taking an active role in identifying technology, kind of transformative technology partners for operations?
100% yes. So when I talked earlier about the maturity of the industry, right? So we're seeing more strategies around Industry 4.0, specifically relating to the operation side of the business, right? So not just the sales and marketing. And the gains there are just huge, right? Especially now with supply chain disruption and being in the news on a weekly basis, companies have come to an understanding that they have to focus on it. Just a kind of word of caution for other companies. Maybe we love working with innovation teams. I think the Pepsi Lab specifically is maybe better than others. Typically, if you don't have the buy-in of the business, the VP manufacturing or supply chain or engineering, then the innovation team can't really move mountains for you. It has to be a partnership between the business and the innovation team in order to really be successful. So after you have this first proof of value, and you have the manufacturing team with a lot of conviction wanting to move faster, then the innovation team can provide access to the right executives and set up the program and kind of pour more fuel on the fire. But it's very hard for them to go from 0 to 20%.
Yeah, they seem to function best as the spark, right? But there needs to be somebody else that's going to pick that up and scale it. So just last point here, maybe there's something else that you'd like to cover as well. You raised, I think in Q3, Q4 of last year, maybe Q4, a nice E round. It looks like it was something like 180 million, just from what Crunchbase is telling me anyways. So first of all, congratulations. I mean, I guess raising a lot of money shouldn't be the goal of a startup, but at least it's kind of somehow a necessary step towards becoming really an impactful company globally. What does this mean for you operationally? Is this driving new product development? Are you focused on moving into new geographies, or what are your growth objectives in the coming year or two?
As you said, we look at fundraising as an opportunity to pull in new partners. These partners could be institutional investors that have experience in scaling businesses globally in one case. And specifically in this round, these partners are industrial giants that we want to go to market together with. So the funding will enable us to, on one hand, aggressively invest in growth within the manufacturing space, right? And going into new segments, going to new geographies, going mid-market, going downstream a little bit to smaller companies. That's one thing. But what's really interesting about the funding round is that it was led by Baker Hughes. Baker Hughes is the largest energy solutions technology. And when we look at Augury, we have kind of two strategic motions. We have a vertical motion, which is growing within manufacturing, as I just kind of mentioned. And then we have a horizontal motion, which is how do we take everything we've learned in manufacturing and bring it into new markets? So Grundfos, as an example, is taking us to the water market, and Carrier into the commercial facility market. Baker Hughes now is taking us into the energy sector, into the oil and gas, the drilling and refining, into power generation, in the future into alternative energies like wind turbines and others. And then we also had Schneider Electric who was invested in as part of the round. And there are multiple strategic avenues we're pursuing with them as well. So to us, this funding is exciting more so because it opens up the energy sector for us on top of just being cash infusion that enables us to grow faster.
Okay, that makes sense. It sounds like you have a great selection and very carefully selected group of partners here. I think we've covered a lot of territory here. Is there anything that we haven't touched on that you'd like to cover?
No, I think we covered a lot of ground. It was a fun conversation.
Yeah, well, again, thanks for taking the time to talk today, Saar.
My pleasure. Thanks for having me.
Thanks for tuning into another edition of the IoT Spotlight podcast. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, please email us at team@iotone.com. Finally, if you have an IoT research, strategy, or training initiative that you would like to discuss, you can email me directly at erik.walenza@iotone.com. Thank you.